Hi everyone, welcome to this session. So today I will be solving a very interesting question. Okay, basically this is a common circuit for us, right? This is called a single stage op-amp, right? Single stage op-amp. Except that there is a no output capacitance here. Okay, but here normally we have M1 and M2 are identical, and normally we have that, right? And M3 and M4 are identical. Okay, identical. So this is our M3 and this is our M4. Okay, but here in this case this M1 and M2 are not identical. Okay, basically the area, like the size of M1, let's say this is 1x. Okay, and the size of M2 is, right, 4x. Okay, like the size is 4 times larger than this M1. Okay, and we have given that the GM of this transistor 1 is nothing but GM1. Okay, so this is our GM1, and here the M3 and M4 are identical. There is no change. Okay, identical, exactly identical. Okay, now the question, and there is like differential voltage applied here. Okay, like we know that the V in plus is nothing but, let's say, V bias plus VCM by 2 plus VD by 2, and our V in minus is nothing but V bias plus VCM by 2 minus VD by 2. Okay, so this is our input. Now here first question is, what is the current through this branch and current through this branch, because these two MOSFET are not same here. Okay, what do you think, what would be the current through each branch? Like, yeah, like you may say this will be uh, on, like ion, like this will be, let's say, Ix, and this will be like 4Ix, right? And our ISS will be nothing but Ix plus 4Ix, so this will be 5Ix, right? But is this right? like like we are talking about this condition only, but what about this condition? This current mirror ensures that the current will be equal each branch, right? Like if there is Ix, the current through here will be Ix. What is the correct assumption here? This. Okay, so this current mirror ensures that the current through each branch is equal. So the current will be like nothing but, let's say, Ix. So Ix, like 2Ix will be nothing but our ISS. Okay, so basically we are assuming both of these two branches, like this is actually happening, the current through both branches equal. Okay, so this is wrong. Okay, this is wrong. The current through is Ix here, and current through here is 4Ix. 4Ix is not correct. Okay, so basically the circuit is properly biased. Okay, we are assuming in this case, like if the current is like if the current is like this is ISS by 2, right? And this is also ISS by 2. So the MOSFET is properly biased. Let's say we are biased in, like, with current sources. Okay, so now we have to find the overall GM of the circuit. Okay, overall GM of the circuit. Overall GM is overall transconductance of the circuit, and we know how to find the overall transconductance. We apply a, like, we short circuit the output node, right, and find the I out with respect to our V in. But here this is our differential pair. Our V in will be nothing but V in plus minus V in minus. So this will be our differential input. Okay, this is called differential input, and this is our, like, we have to find this. Okay, so we need to find the short circuit I out over V in. Okay, so let make the circuit again. Okay, so let's draw here. So this is here. Actually this is very interesting circuit. Okay, just look at it. So this VDD will be our AC small signal ground. So this will be open circuit, right? This is the ideal current source. So right, so this will be our V in plus, so this will be our V in minus. So this is our GM1 and this is our GM2, and we don't know the GM2 value. Okay, so we have only GM1, so we have to find the overall GM in terms of something terms of GM1. Okay, so this is our aim. Okay, so now this will be our short circuit to the ground, I out, and we have to find the small signal current, and we have to divide it the V in plus minus V in minus. Okay, so this is our overall GM. So now, like for a ideal case, when these two are identical, what we do a symmetrical behavior. Okay, because this is a low impedance path, and this is also a low impedance path. That is nothing but 1 over GM3. Okay, so we do the symmetric circuit there. But in this case, is this possible here? No, right? This point is not AC ground. Okay, AC ground is not possible here, and this point is also not AC ground. Okay, this is not AC ground. So how to approach this to find the overall GM? Like if we have a like AC small signal ground, this and this, so our calculation becomes so easy. Okay, so we can see that this current, let's say, okay, so let's say this current here, so we have to find the current upper in the upper window and the lower window. Okay, so we have to find these two current, and this will be nothing but overall I out here, right? So what we can see is, so our, okay, let's say I out will be, so this is the current direction, so this will be nothing but minus of, let's say this is I1 and this is I2. Okay, I1 plus I2, right? Like if we apply a KCL here, so this will be like this, right? So these three branches are outgoing from this node. Okay, so this is the, so if we apply a KCL at here, so we will be getting this. Okay, now this is not a AC small signal ground, so there will be a voltage. So let's say this is Vx. Okay, okay, and okay, forget about this voltage because this is the trivial case basically. And our rds of each MOSFET is infinite. Okay, we have neglected the channel length modulation. Okay, so now if we measure a current here, okay, so now we can see that this current, what will be this current, the small signal current. So this will be nothing but our small signal current will be, this is our Vd by 2 and this is our Vx. So our Vd by 2 minus Vx times Gm1. Okay, so this is our current, and this is a series path, right? So the same current will be flowing through this path as well. Okay, understood, right? So this will be nothing but our same current, and this current is nothing but, so what is the dependent current source here, like in this path? So this will be nothing but minus Vd by 2 minus Vx times Gm2, right? So these two current have to have equal, like this current must be equal, right? So let's write it. So minus Vd by 2 minus Vx, so this is minus, okay, and times Gm2. Okay, so we don't know the Gm2 value. Okay, so this is our first equation. Now we can see that basically this is a series path, so the current will be same, right? So the current flowing through this path will be the current flowing through this path, and this will be negative. So I have made a negative sign, like, okay, this will be this, right? So this will be the correct expression. So basically this, the dependent voltage source here will be because this is a minus Vd by 2 minus Vx, right, flowing in this path. So this will be negative, so that it can make a series path and this current will be equal. So this is our expression. So this is minus Vd by 2 minus Vx Gm2. Okay, now we can see that this and this current is also nothing but this current, right? And this current mirror effect making this current is like this, right? Sorry, so this current is like this because, okay, 1 minute. So this current is flowing in this path, right? The Gm, like this current, like Vd by 2 minus Vx times Gm1 is flowing through this path. So the same current will be flowing through this path, right? Will be the direction. So our this current, like the current through this path will be like in this direction will be nothing but this current, right? So this will be nothing but Vd by 2 minus Vx times Gm1. But we have assumed that the Ix will be in this way, right? So here we are getting basically the I out is nothing but 2 times of this current. Okay, So let's do that. So this current, okay, so this will be nothing but our minus ion. Okay, let's do that. And what will be our I2? So I2 we have assumed in this way, right? In this way, like in this way. But okay, let's do that. So this way the current is this, right? So this current is flowing in this way. If we consider this case, so this will, the I2 will be negative of this, right? So this will be negative of this. So this will be plus, right? So this will be plus of Vd by, okay, minus Vd by 2 minus Vx times Gm2. Okay. So we have to add these two current. Okay. Now if we add this, IT will be nothing but our I1 plus I2. Okay. So this is our I2, right? So I2 is our I1 is nothing but Vd by 2 minus Vx times Gm1. Okay, so this is Gm1, and this will be nothing but minus Vd by 2 minus Vx times Gm2. So this is our expression, like equation number 2, and this was our equation number 1. So now we have to just replace the Vx value over here. Okay, so now from this equation, what will be our Vx value? So if we take common here, so this will be nothing but, let's say, Vx into, so this will be, okay, let's do, so this will be our, this is plus and this is minus, so this will be minus of Vx times Gm1 plus Gm2, right? And this will be equal to minus Vd by 2 times Gm2 and minus Vd by 2 times Gm1. Okay, so this is our expression. So from here we can find the Vx value. Okay, so if we cancel this, so this will cancel and this will get plus, right? So this will be Vx will be nothing but our Vd by 2 is common and Gm1 plus Gm2. Okay, divided by, am I doing something wrong? Okay, let's do, so Gm1 plus Gm2, is this correct? Okay, let me check. So here we have this equation, right? So if we take common Vx, okay, let me do that. So minus Vx is common, so this will be Gm1 and this will be okay, this will be okay, this will be minus Gm2, right? Because this is plus, yes, this is minus Gm2, so this will be minus Gm2, this will be minus Gm. So this is our Vx value, so we have to put Vx over here. Okay, this and this. So now if we do that, so we have IT, like I total, this will be nothing but okay, let me do, so this will be our, okay, so we can take Vx common again. Let's say Vd by 2 common first, so this will be Vd by 2 times this will be Gm1 minus Gm2, right? And if we common Vx, so this will be okay, minus Vx times Gm1 plus Gm2. Okay, okay, so what will be the value? So IT times okay, now we have to calculate what will be the Gm2. So we can see that both case the I is exactly equal, right? So now we have Gm right here, right over here, right? So the Gm2, what will be the Gm2? We know that the expression for Gm1 is nothing but root 2 times IDSS by 2, because the current is same, right? Times neon Cox W over L. Why we are using this expression? Because we haven't here VGS minus VTN values. Okay, so this is the correct expression for this case. Okay, because we have all the given parameters. So this is our GM1, right? This is our GM1, but and we have the GM2 is nothing but 2 times ISS by 2 mu n Cox, and this will be 4 times W over L, right? Because the size is 4 times, so this will be nothing but so this will be nothing but 2 times Gm1. Okay, so this is our Gm1, right? And it is given in our question, so this will be Gm1. Okay, 2 times Gm1 Gm2. So now put here, so okay, so now if we put what is our Vx value, so our, okay, let me check. Oh, So this is our Vx value, right? And we have to put here. So now IT will be nothing but Vd by 2 times Gm1 minus Gm2 minus, so this will be nothing but Vd by 2 times Gm1 plus Gm2 divided by Gm1 minus Gm2, and here is also presented Gm1, so this will be square, right? So now if we take common from here, okay, let me do. So this will be our IT by Vd by 2 common, so this will be nothing but Gm1 minus Gm2 minus Gm1 plus Gm2 whole square divided by Gm1 minus Gm2. So now we have to just take IT by Vd. So this will be half of this, right? Now if we put, so this will be Gm1 minus 2 Gm1, right? Because the Gm2 is nothing but 2 times Gm1 and minus, so this will be 3 Gm1 whole square divided by, so let's say Gm1 minus 2 Gm1, okay. So this is the case. So now if we do further calculation, so this will be IT over Vd, this will be half times minus Gm1 minus 9 Gm1 square divided by minus Gm1, right? So okay, so this Gm's cancel on, so this will be nothing but overall Gm, right? So this will be nothing but half times minus of okay, so this cancel, so this will be minus of Gm1 times plus of, what will be the value, plus of Gm1, right? So this will be 9, right? So this will be 8, so this will be 4, right? So this will be 4 Gm1. But is this correct here? So I think it is not correct. I have made some mistakes. Okay, okay, let me check. Okay, let me check. Okay, let me check once. So this is the current flowing downward, and this is the current also flowing, this current is downward, and if we make a negative, so this will be upward. Okay, so now let me check. Okay, so okay, let me do here. Okay, so basically actually I made some mistake, the answer will not be this. Okay, so let's do once. Okay, so if we do this, so now we can see Vx value is correct or not. Okay, let me check. So okay, let me do here. So our Vd by 2 minus Vx will be exactly equal to the minus of minus Vd by 2 minus Vx, and this will be into Gm1 and this will be Gm2. Okay, this is the expression, and if we make this, so this will be, so let Vd by 2 common over here, and this will be Gm1 times, this is plus and this will be negative. Okay, so this is the case, and if we take Vx here, so this will be Gm2 and this is get plus. Okay, so this will be Gm1. Okay, so this is our Vx. Okay, so Vx is nothing but Vd by 2 times Gm1 minus Gm2 times Gm2 plus Gm1. Okay, so one thing is right. So and our IT is, total IT is nothing but the current flowing. Okay, total IT will be, let's see, this is IT, this current and this current plus of this current and this current, right? So So this current, so this current and this current will be equal, right? So we can directly make two times this current is, what will be the this current? So this will be Vd by 2 minus Vx times Gm1. Okay, so this is our total current. Okay, so okay, this is correct. Okay, now if we put Vx over here, okay, so 2 times Vd by 2 minus Vd by 2 times Gm1 minus Gm2 by Gm1 plus Gm2 into Gm1. So this is the case. Okay, now so these two to cancel, so we can directly write It by Vd will be nothing but this cancel, so this will be 1 minus Gm1 minus Gm2. So Gm2 is nothing but 2 Gm1, right? So this will be the case, and this will be 3 Gm1 times Gm1. Okay, so let's do. So this is our overall Gm, right? So this will be 1 minus of Gm1 divided by 3 Gm1 into Gm1. So this cancels. So we are having Gm equals 1 minus 1 plus 1 by 3, right? Yes, this is the correct answer. Okay, so we are getting 4 by 3 into Gm. So actually previously I think I made some mistake. Oh, forget it. So this will be the answer. Okay, so this is our overall Gm, and this is a very interesting circuit. Okay, and please forget this previous analysis. Maybe I did something wrong like in the during this video, and it can happen. Okay, so basically now I am going to make to do a trick. Okay, what we have find that Gm2 is nothing but 2 times Gm1, right? And our this is for M2, right? And for M1 our Gm transconductance is Gm1 itself. So to find differential pair, to find the overall transconductance of a differential pair, what we do? We do a formula. Okay, this formula is nothing but 2 by 1 over Gm1 plus 1 over Gm2. So this is very helpful. Okay, so this is a trick. Like you do not have to do all these mathematical equations. Okay, you can directly find the Gm of this two circuit and you can equate overall Gm. So what will be the answer here? So this will be nothing but 1 over Gm1 is 1 over Gm1 itself, nothing but 1 over 2 times Gm1. Okay, so now if we do, so there will be 2 times, so 2 Gm1 times 2 plus 1, right? So this will be nothing but exactly 4 Gm1 by 3. So this is exactly the same expression. Okay, so this is the trick. Okay, and I actually want to do the this calculation first, and then you learn this trick. Okay, basically doing this type of calculation is build your circuit analysis more rigorous. Okay, thank you everyone.